In the last few videos, we looked at the different conformations of cyclohexane. And obviously, cyclohexane is just one ring, so it would be a monocyclic compound. The official IUPAC way of telling how many rings you have is how many cuts does it take to make an open chain alkane. So if I just made a cut between those two carbons, I have an open chain alkane, and it took me one cut to get there. So obviously, cyclohexane is monocyclic. What about if I had a cyclohexane ring, and then I had another ring fused to it like that? Obviously, there are two rings here, so this would be a bicyclic compound. Once again, if you were to use the IUPAC way of figuring out how many rings you have, you would make a cut here and a cut here, and now you have an open chain alkane. So it took you two cuts to get there, so you would classify this as a bicyclic molecule. Now these are very easy, simple compounds, but for more complicated compounds, you'll need to remember that IUPAC rule to figure out how many rings you actually have. Let's go ahead and redraw that second molecule here, and let's look at it in some more detail. So I had a cyclohexane ring, and then I had another ring fused to it, like that. Now, the carbons that are shared by both of these rings, so this carbon and this carbon, those are called your bridgehead carbons. So let's go ahead and write that. The bridgehead carbons. And when you're numbering your bicyclic compounds, you want to start at the bridgehead carbon, then number along the longest path, then the second longest path, and then finally the shortest path. So let's go ahead and do that. Let's start with the top bridgehead carbon. We'll make that number 1. And we're going to number along the longest path. So the longest path will be going left. So that's 1, 2, 3, 4, 5, and 6. And now the second longest path. Well, we can just continue, and it would be 7 and 8, since that's the second longest path. The third path, the shortest path, is usually the one between your bridgehead carbons, and there are no carbons between our bridgehead carbons, so we're done in terms of numbering our compound. The general formula for naming a bicyclo compound, all right, we've already determined this is a bicyclo compound, so you would have bicyclo here, and then in brackets, you would put the number of carbons in the longest path excluding the bridgehead carbon, which I will represent here with X. And then Y is the number of carbons of the second longest path excluding the bridgehead carbon. And then Z is the number of carbons in the shortest path excluding the bridgehead carbon. And then you finish everything off with the alkane. So how many carbons are there in this molecule? So for this example, let's go ahead and name it. We've already determined that it's a bicyclic compound, so we'll go ahead and write bicyclo here. And X, again, is the number of carbons in the longest path, excluding the bridgehead carbon. So we're going to find the longest path, which is on the left here, and we're going to ignore the bridgehead carbon. How many carbons were there? 1, 2, 3, and 4. So we'll go ahead and put a 4 here. All right, Y was the number of carbons in the second longest path. Well, that was over here where we had this carbon and this carbon, again, excluding the bridgehead carbons. So that would get a 2. And finally, the shortest path, which was how many carbons are there between my bridgehead carbons. And there are, of course, 0 carbons between my bridgehead carbons. So if there are 0 carbons between your bridgehead carbons, obviously your bridgehead carbons are bonded directly together, which we can see in the dot structure. Finally, how many carbons are there total? There are 8, and we know that means octane. So the final name for this molecule is bicyclo 420-octane. Let's do another one following our general formula here for naming a bicyclo compound. So let's take a cyclohexane ring, and let's make this a bridgehead carbon, and we're actually going to put a carbon between our bridgehead carbons like that. Now, this is kind of hard to see when it's drawn this way. So usually you'll see it drawn a little bit differently. Usually you'll see it drawn with a little bit more three-dimensionality to it. So hopefully we can do that here. So it would look something like this. All right, so let's find our bridgehead carbons here, right? So we know that this is a bridgehead carbon, this is a bridgehead carbon. Those correspond to these guys over here. And how many cuts would it take to turn this into an open chain alkane? Well, let's go ahead and look at the drawing on the left, and if we cut it right here, and we cut it here, we can see it's now an open chain compound. So it took 2 cuts, so it's bicyclo. So let's go ahead and put those bonds back in there like that. So it's a bicyclo compound. So we can go ahead and start naming it as a bicyclo compound. So this is bicyclo. We need to go ahead and number it. So let's start with our bridgehead carbon. So we'll start with this as our bridgehead carbon. Find the longest path. Well, it doesn't matter if I go left or right here since it's the same length each way around. So I'll just go to the right. So 1, 2, 3, 4. Second longest path. So I'm going to keep on going this way. So 5 and 6. And then finally the shortest path, which is the 1 carbon in between my 2 bridgehead carbons, which would then get a 7. So 7 total carbons. All right, so when I'm naming this, I need to put my brackets in here. And I put the number of carbons in the longest path, excluding the bridgehead carbon here. So how many carbons were my longest path, excluding the bridgehead? Here's 1, and here's 2. So I'm going to go ahead and put a 2 in here. And then I go to my second longest path. Well, that was over on this side, and there are also 2 carbons on my second longest path. Obviously, it's the same length as the other one. So it's 2, 2. And then my shortest path. How many carbons are there in my shortest path? Not counting my bridgehead carbon. There's 1. So I go ahead and put a 1 here. So I have bicyclo 2210. And then my total number of carbons is 7. So this is a bicyclo heptane molecule. So bicyclo 221 heptane would be the official IUPAC name for this molecule. This molecule turns up a lot in nature, so much so that it actually has its own common name. This is also called norborane. So let's go ahead and write that here. So this is norborane. Again, a structure found often in nature. All right, let's do one more example here. And let's make it look similar to the to that norborane molecule. So we'll have it go like this. All right. So definitely is a little bit tricky to draw these molecules here. So let's put some substituents on this molecule. So I'm going to attempt to draw the same molecule over here. And we're going to take a look at 2 different ways to number it and see which one turns out to be correct. So here I have the exact same molecule on both sides here. And let's see how to do this. So let's first find our bridgehead carbons. So here are my bridgehead carbons right here. Now when I start numbering, I could start at either one of those bridgehead carbons. So if I identify my bridgehead carbons over on this one, I could start numbering with either of these being number 1. So let's just make this number 1 here. So if that's number 1, I next go to my longest path. So that would be going to the right here. So this would give me a 2 for this carbon, a 3 for this carbon, a 4 for this carbon, a 5 for this carbon. Next, the second longest path. Well, I can just keep going, make that a 6, make this a 7, and then finally my shortest path, which is up here at the top. So that would be 8 total carbons for my parent name. On the dot structure on the left, again, the exact same dot structure. This time I'm going to start with the opposite bridgehead carbon. So I'm going to start with this bridgehead carbon and then follow the same rules. So longest path, excluding follow longest path, which would be to the right here. So 2, 3, 4, 5, 6, 7, and then 8. So which one of these numbering systems is the correct one? Remember, our goal is to get the lowest number possible for our substituents. And if I look at the example on the right, I have a methyl group in the 7 position and a methyl group in the 8 position. The example on the left has a methyl group in the 6 position and a methyl group in the 8 position. Since I want to give my lowest number possible to my substituent, I'm going to not number it the way on the right. I'm going to go with the way on the left here. So let's go ahead and start naming it. We already know this is a bicyclo compound, and we have 2 methyl groups, one at 6 and one at 8. So we can start naming it by saying 6,8 dimethyl. And then we know this is a bicyclo compound, so bicyclo. And then in the brackets, we're going to do the longest path first, excluding the bridgehead carbon. So the longest path is on the right. How many carbons are there in the longest path? There are 3 excluding the bridgehead carbon, so we'll go ahead and put a 3 in here. Next, the second longest path, excluding the bridgehead carbon. Well, that was these 2 right here. So next there will be a 2. And then finally, the shortest path, excluding our bridgehead carbon. There is only 1 carbon in our shortest path. So we put that in there, and then there were 8 total carbons, so it is octane. So the final IUPAC name for this molecule is 6,8-dimethyl bicyclo 3,2,1 octane.